got our crank sprocket here, all spicked and spanned. And it just goes on to the crankshaft clean and dry. And the idea being, as long as your oil seal doesn't leak and create muck, that's a slop fit clean and dry. So as long as your oil seal doesn't leak and create tar, then it's no problem to get that off next time. The crank bolt, what did I do with the old one? It's probably up here. Just confirm that they're the same length. What I don't like, and they always frickin' do this, is it's hard enough to get a hold of one of these, and now they've reduced the head height to 2/3 instead of what it was before, and it's got this stupid internal 12-point inside as well, so the head's even less structurally sound. But they are the same length, so that's the important part, and they're the same diameter. And again, it says to install it clean and without grease or oil. Now I'm gonna put the tiniest little bit of anti-seize on it, just in case. I mean, other than it probably having been over torqued the last time, getting the old one out wasn't a big deal, and the threads were still like new, despite the condition of the head. So it just makes it a little easier, so that hopefully next time I can undo it with an impact gun instead of having to put the hold on it backwards and then pull for all I'm worth with a Johnson bar to get it undone. The big thing too being, the bigger thing being the head. You want to put a little bit, just a little bit. You don't want it all over the place and getting it all over the timing belt and all that crap. But you want a little bit on the head so that when you're tightening it, you're not getting bound on the sprocket. You want the torque to be on the threads, not the head stopping the bolt from turning. So I'm going to put the little tiniest little bit on the threads just so it's got something, and a little bit on the head so that it's going to be not grabbing and binding on the sprocket. And then we'll install this bolt. And then I'll have to get the hold down tool mounted again here. And I just read the book. It's for this bolt, it's 88 foot-pounds plus a quarter turn or 90 degrees, which is a real pain in the butt. That's why we have the holding tool, because I'm going to torque it to 88, and then I got to use the Johnson bar to try and get another quarter turn out of it somehow. So we'll do our best. It's a brutal thing to have to do, especially when you're not on a hoist. You're working on the ground. It's not a good time. So there we go. Looks like I put a lot on, but I didn't. You can still see the bolt through the threads, and I put a coating on the head. So that should be good to go in there. And it should spin all the way down and make contact by hand. Otherwise there's something wrong with the threads. It's definitely stiff, but the threads on the bolt I noticed were actually mashed a little bit. Doesn't want to go, of course I didn't get the socket either. Doesn't want to go all the way. Let's see if we can do it with the socket. Now it'll be pretty hard to cross thread this, or to damage the threads on this high tensile bolt, but there we go. Alright, so that's got that snugged, and the anti-seize didn't squirt out everywhere, which was what I was trying to avoid, which is good. So now we need our holding tool again, which it actually works out freaking beautifully, and I'm sure that's why they built it this way, my dad and my grandpa. There's a hole in the plate here that's supposed to be for that dowel pin for the harmonic balancer pulley, and it actually works out that I think the angle of this is going to be pretty much perfect for it to only turn the crank a little bit and be against the control arm so that we can torque the crank bolt. last sanity check before we do this, because this is a one-time thing. We replaced the oil seal. It's all good to go. We got the sprocket all cleaned up and ready to roll. Got the new bolt in there. Nothing else has anything to do with the crank sprocket. So we should be good to torque this up final, and then we can turn it both ways to set the crankshaft in the right place to do the timing. And then we're good to move on. So those are tight, that's kind of ready to go. Let's get the torque wrench going here with the socket. Don't know if it's gonna clear this. Just barely, okay. All right, so 88 is what we want. Let's just do 50 to start. So it says the 88 plus the quarter turn are 90 degrees. And it says down lower, the quarter turn can be achieved through 2 eighth turns, but it doesn't say whether the 88 should be in one shot or not. I think the 88 is pre-stretch, so let's do it in 2 here. Let's do 50 and then 88. There's our 50. And then there's 88. Oh, I have to get this there. There's our 88. Okay. So then you can put the torque wrench away. I mean, you can use the torque wrench to to do the quarter turn if you want, but there's no point because there's no spec to go by anyway. So I'm going to go to the breaker bar here. And then now the biggest thing is to figure out how to gauge a quarter turn. So there's a letter on the face of the bolt there that's pretty much in line with that top bolt for the holder. So we'll just take that till it's at the 3 o'clock position and call it good. I can't tell what letter it is, but let's do this just to make sure we're looking at the right one. There we go. All right. So the idea with this now is to try and do this in a fluid motion. So there's probably our 8th. And yeah, we're pretty much halfway there. So then if I push this down to the floor again, that should be pretty close. Oh, maybe. Okay. Let's see how we did. That's pretty close. It says do it in 2 stages, but I don't know if you're causing a problem to add more to it or not. That's pretty good. So I would say we call that good. So we can remove the... Actually, I should probably try and turn the crankshaft back closer to where it's supposed to be first. But the nice thing now, of course, is we can adjust the crankshaft easily, one way or the other, using the bolt again now. All right, so I'm just gonna take this off. Not really any point in showing you that. And then our crank bolt is done and over. Seal is done. So then the next job will be dealing with the very messy water pump. So stick around for the ride, it's gonna be a good one. So this sprocket here, that's our water pump. There are 3, I believe 13 millimeter head cap screws that hold it in. There are also internal hex inside of those, but I wouldn't use that unless you have to. The main downfall with at least the Volkswagen water pumps here. This is the new one. It's going to be way too close for you to see. I don't know if all of them are like this, but the Volkswagen water pumps, I'm pretty sure this is a plastic impeller with a steel insert, and then that's pressed onto the shaft. So what happened with the one that we had was some part in here slipped. So the impeller was slipping on the shaft, and so the engine started to overheat. So I don't know, the water pump that's in there doesn't look like the same kind of sprocket as this Volkswagen one. So maybe there's something available aftermarket now that has both maybe a aluminum impeller and also a better spline on the shaft so that the impeller can't slip. In any case, I think those might be smaller than 13. I may have lied to you. Without hurting this pin here, we are actually even smaller than 12. Didn't think they were 10s, but maybe they are. Okay, so they are in fact 10 millimeter head, so I lied to you before. I figured they would want to use 13 because that's Volkswagen's favorite size, but not in this case. Of course, this power steering and coolant hose mix is right in the way. What I'm also going to do here is raise the engine kind of as far as I dare so that hopefully the coolant goes, will you stay put? Hopefully the coolant goes away from the water pump so we don't have quite so much flopping out on the ground. So let's try up here as much as we kind of dare without starting to hurt things. And it will also make it easier to access the water pump itself. It's probably pushing the envelope here for height. Don't want to hurt any hoses or anything. So that gives us better access to the pump. So we're about to see how many gallons of coolant we're still going to lose here. Hopefully not much. Alright, so what is going to get drenched with coolant here if it leaks everywhere? Alright, so should be as simple as, oh, of course I say that, but you know. Alright, challenge accepted. That works well, not. There's really not much to pry against. Why won't you come out of your home? Well, course, everything around it is plastic. This is plastic, that's plastic, that's part of it. So, I guess we could try prying against the injection pump sprocket though, carefully. Alright. I just opened up the... That's in the way again. Just opened up the water pump section of the manual as well. So we have those torque values. O-ring, it says always replace, of course, but we got a new water pump that has a new O-ring on it. So we don't have to worry about that as much. I don't know if this is going to do what I want it to do. Without hurting anything. Come on, water pump. There we go. Let go of your home. Ah, yes. Okay. Apparently we need a pan. Jeez. Never fails. Okay, now that we've made a thorough mess, which this right here, that crank sprocket is the reason you do the oil seal first. Because now it's all soaked in coolant. So I've got a giant pan underneath to try and catch whatever it'll catch. Such a bad design. Of course, you're supposed to drain the coolant, which I did. But the only way to get the coolant away from the water pump is some kind of a block drain, and I don't even know if these ones have one or where it might be, and I don't want to mess with it. So we're going to do this the messy way. So okay, so apparently there's a crap ton of coolant that doesn't get drained from the block, which is friggin' typical. Yeah, so that's too bad. This this water pump, whoever's it is, it has a cast impeller and no insert. So that's too bad that I'm putting a... I mean, you would think the Volkswagen one should be better, but nope. But it's okay. I would hope by now that the water pumps, I mean a long time before now since the car's 20 years old, would hope that the water pumps that Volkswagen are producing are gonna last the 160,000 for the belt at least. I can't tell. Looks like this water pump is a HEPU or HIPU. So I'll have to keep that in mind because I would much rather be putting a water pump with a steel impeller and, you know, less chance of slipping on the shaft than one that's going to do the same thing as others have. But anyways, that gets that out of the way. With a thorough amount of coolant all over the floor. But, you know, what can you do? So, it's just a matter now of cleaning up the hole there, which you can't really see very well, but in there is still some coolant down further, but in around that area there, clean up the sealing ring and the flange where the new pump mounts, and I won't bother putting anything on the flange to the engine because the O-ring is what does the sealing. We'll put a bit of coolant on the O-ring so it's not going in dry, and we'll put anti-seize on the cap screws, and then we're ready to reinstall. And I believe the torque for those 3 bolt. So those are 11 foot-pounds. So we'll get them all cleaned up and lubricated and put in and torqued with the new water pump. and then we can move on to the more fun stuff. So let's put the new water pump with our piece of crap plastic impeller in here. So then this should only fit in here one way. That post I was talking about before has to be in the same place, of course. And there is also a notch. Can't see it, I can't even see it. There's a notch up on the top side there that fits this notch right here. So it can really only go in there one way. So let's do it. Without dropping it would be ideal. And it would be nice to see if we're lined up with the bolt holes. I think we are. I can't get the O-ring to go in, of course, because it's a little bugger. Might have to pull it in with the cap screws, which I don't like to do, but maybe. Yeah, it's not going to cooperate as per usual. So let's try with the cap screws here. All right. So now we're just going to start with the ratchet and try and take them all in at the same pace so that we don't distort the O-ring or anything like that. And it shouldn't be hard to make the O-ring go in. Like, I'm turning this socket with my fingers and it's a pretty small socket, but it's more than you can do to just push it in when you're not able to get on the end of it very easily. Like, I'm trying to push sideways from above, which doesn't work very well. Okay, we've reached the bottom of the threads at least. The bolts are starting to tighten. And it would just be good to be able to see. Yeah, it looks like the flange has bottomed against the block, which is good. We got our post in the right place for the timing cover, and the notch is in the slot, the only way it fits. So now, we should be good to torque these guys. And get an adapter to use this nice small 1/4 inch drive socket on the 3/8 drive torque wrench. And like I said before, we want 11 foot-pounds. I'm going to try and use the inch-pound torque wrench because it's nicer to use, smaller, I think more accurate than the other one. So, 11 foot-pounds to inch-pounds, so times 12. 11 times 12 is 132 inch-pounds. There's 132. Now these aren't really doing much. They really only have to hold back against the cooling system pressure, and that's about it. And of course support the tension of the timing belt, which has got to be one of the stupidest ideas they ever came up with, to have the water pump in the timing belt. But anyways, nothing I can do about it. But the O-ring is doing the sealing of the coolant. The cap screws are just to hold the pump in place, and of course to support the timing belt. Okay, so there we have it. Water pump is done. This pump is much stiffer than the other one, being new. So I wonder what we should do for crank sprocket cleanup. Really hate to spray like brake clean on there, but we'll figure that out. Doesn't have to happen right now, I guess, but the problem with coolant is it doesn't really ever dry. So it's not like it's going to all be evaporated and gone when we come back to it later. But we'll leave it for now. I want to make sure it's all cleaned up before we put the new belt on, but we've got our water pump change now. So now we can come up top to the more fun stuff with the camshaft and get the cam sprocket off and get old camshaft out and get our new stage 2 shaft in, new oil seal, and then we're ready to start putting the timing belt, the new timing belt on after that. So that's what's next.